Hey guys, good morning all. Welcome to the flight dynamics course. Today we are going to see the topic on dihedral effect and lateral control. So in flight dynamics, the main controls of laterals and the effect of wing position due to the lateral effect that we'll see here. So the introduction to the dihedral effect. The dihedral effect refers to the aircraft natural tendency to roll back to level when they experience a side slip force. So see, we already seen the lateral control of the position of wing with the root and tip with the varies of angle beta side slip. So it is a primary influence by the upward angle, that is we call it as a dihedral angle. If the angle is a downward, that we call it as a anhedral of the wing position from the horizontal plane. So this dihedral effect contributes significantly to lateral stability and passive controls in the flight operation. Dihedral angles create a restoring forces that opposes and unintentionally that role, aiding its self-correction. The understanding of the dihedral effect is essential in designing of stable aircraft and highly maneuvered aircraft. From the figure, we can see that starboard and port side wing. The starboard side is wing is in flat to the horizontal surface, whereas in the port side wing is deflected in a side step angle beta. This increases the angle of attack and the lift force will starting decreasing. So this will make the aircraft more stable during the maneuvering condition. Next, coming to the wing dihedral angle and it impacts on stability of the airplane. The dihedral angle is the upward tilt of an aircraft wing, which is relative to the horizontal axis. A positive dihedral angle enhances the lateral stability by counteracting the rolling disturbance. This angle of affect the aircraft response to turbulence and helps to maintain the aircraft in the level flight during the slight slip condition. Also, in the crash landing, this also helps to operate the stable landing during the runway. The aircraft with the larger dihedral angle are more stable laterally but less aligned with the horizontal line. So the military jet offers a have high and little or no dihedral to minimizing the maneuvering. Why? Because the fighter aircraft will have a more unstable condition, whereas the normal trainer aircraft will have the more stable condition. This is the impact on dihedral angle in the stability part. Next, coming to the dihedral effect into the side slip. In a side slip, the windward due to the wing experience increase the lift due to its dihedral angle. This increased lift on the windward wings causes the aircraft to roll back towards level flight. This dihedral helps to return the aircraft to the neutral roll position after encountering a side slip force. The dihedral effect works with yaw and lateral dynamics to achieve stable flight. The side slip recurs through dihedral effect, is crucial for aircraft stability during crosswind and turbulence landing. From the figure, we can see the one engine is failure and another wing is operated, which has produced a side slip, which also makes a started to yaw. This dihedral effects will also helps to maintain the stable condition by uses of rudder and the position of wing in the dihedral effect. Next, coming to the list of factors which influencing the dihedral on its effects. One is wing shape, aspect ratio, and the sweep angle. All affect the strength of the dihedral effect. The high wing aircraft neutrally exhibits a strong dihedral effect due to a fuselage placements below the wing, and the forward sweep of wing can reduce the dihedral effect, which affecting the lateral stability. Coming to the wing tip design, such a winglet can alter lift distribution, influencing lateral control. This aircraft weights and center of gravity also impacts how the pronounced the dihedral effect will be created. So this low wing condition and high wing condition also helps to understand the influence factors of dihedral with wing shape and position as well the aspect ratio and sweep angle. Next, coming to the dihedral effect and the lateral control systems. In a lateral controls involves aileron that rolls the aircraft by changing lift distribution on each wing side. So dihedral angle complements aileron by stabilizing unintended roll movements, which excessively dihedral effect can reduce the responsiveness of aileron-based roll control. Coming to the designer part, we must be balance the dihedral with aileron effectiveness for precise lateral control of the airplane. Next, the right combination enhance the rolling authority without compromising the stability. So this is the controls and the dihedral influencing the design of an airplane for the stable condition. Next, coming to the dihedral effect and the sweepback effect, both dihedral and sweepback angle contributes to the lateral stability, but in a different way. Let us take the sweepback effect. Stability rolls by creating a lift differentialing along the sweeping duration during side slip. So this dihedral effects relies on wing tilts, while the sweepback effects relieve on wing shape. So wing tilt and the wing shapes plays the major role. So modern aircraft often use a combination of dihedral effect and the sweepback position of the wing mix, which makes the airplane optimized their stability. So finally, the understanding of this role of both effects is crucial in aircraft design for a balanced, controlled, and stable aircraft design. So next, coming to the adversia and dihedral effect. Adversia occurs when the aircraft yaw push opposite to the direction of roll due to aileron deflection. So this means the both yaw and the roll should be coupled, whereas the both rudder and the aileron should operate in the opposite direction. Whereas this adversarial case, both will operate in the same direction. So dihedral effects helps to counterattack the adversarial by stabilizing the roll direction during coordinate turn. So dihedral assists in the naturally aligning the aircraft with the intended flight path in a coordinate turn, dihedral minimizing the need of excessive rudder input in into counter adversarial. So the relationship between dihedral effect and the adversia is a key in achieving smooth and balanced turn of the airplane during maneuvering. So the effect of dihedral in a high wing and the low wing aircraft so is different cases. In a high wing aircraft typically exhibits a strong dihedral effect and enhancing highly stable airplane operation. In a low wing aircraft may need to more pronounced dihedral angle to achieve comparable lateral stability, and high wing design naturally has its own or inbuilt or inherently stable the role due to the center of gravity below the wing. So dihedral must be adjusted based on the wing placement to maintain stable lateral control and the structural configurations significantly influencing the dihedral effects role in a stability operation. Coming to the dihedral effect in the aircraft maneuverability, increased dihedral angle impose stability but can reduce roll align, affecting maneuvering. The aircraft required high maneuverability, such as fighter jet, often use minimal dihedral. For general aviation, the modern or moderate dihedral angle provides a balance between stability and control response. The pilot of highly stable aircraft required less aileron input to maintain level flight. Dihedral effect adjustments cater to specify performance needs to different aircraft types. So in conclude of this session, so it is important to dihedral effect in flight dynamics. The dihedral effect is fundamental aspects of lateral stability, essential for safe and controlled flight. Coming to the next point, it enables passive recovery from side slip and minimum pilot workload to maintain level flight. Next, the understanding the dihedral effects allows for optimal design, choice in lateral stability and control, the proper dihedral angle, turning, enhancing the aircraft handling quality based on operational requirements. Mastery of dihedral dynamics is critical for pilot and engineers in ensuring reliable aircraft performance. So thank you guys. We'll see in the next class. Thank you.